Okay, reviewing 5-3 part 2, problem number 49. We have a Ferris wheel, right? Okay, this is 4 feet. Okay, now, says that if the radius of the Ferris wheel is 36 feet, so this distance here is 36 feet, right? How far above the ground will Domingo be when his seat reaches the top? That's just an addition problem, isn't it? That's right. You guys got A? How far? Okay, the radius of the Ferris wheel is 36. When the seat gets right here, how far off the ground? How far is it from here to there is what it's asking. Okay, you got it. Okay, part B. I don't know. I haven't got that far. Let's look at B. The Ferris wheel rotates 300 degrees counterclockwise and stops to let another passenger on the ride. How far above the ground is Domingo when the Ferris wheel stops? Okay. No, I think he's talking about right here. And it goes, so if he gets on the seat and it rotates 300 degrees, 300 degrees is about right to there, right? So, yeah, so how far, what's this angle open up to be? And Trevor's answering that question. If it's 300 around there, plus another 60 would get you all the way back. So it's 60 degrees right there, right? And it wants to know this distance right there. What do you think? Actually, this picture is not proportional, so I wouldn't say a little bit over 4. It's actually not even close. Well, let me ask you this. I mean, there's a couple different ways we can do this. But this is a 60-degree angle, right? Well, we already know this is 60 degrees. We're doing it in degrees. Let me ask you this. How far, if you were right here, how far off the ground would you be? Say that again. I'm not following you on that one, but how far would this be off the ground, you guys? 40 feet? Because that's a distance from here to here is 36, right? From here to here is 4, so that's 4 plus 36. So we could figure out the angle. We could draw a line up here. We could make our right triangle right there, right? How much would this angle be right here? What would this reference angle be right here? 30 degrees, yeah. That's 30 degrees, right? Yeah. And we know the radius is 36. And we know that okay, so we're going to use SOHCAHTOA right here, you guys. I have this right triangle right here. Let's look at the 60-degree angle right here. And we have the hypotenuse is 36. And we have this angle up here is 36 degrees. So we have, let me draw it bigger up here. We have a 60-degree angle right here. We have the hypotenuse is 36 feet. I want to find that distance right there, right? Which two distances do I have? One distance and the other one I want. I need the adjacent, and I have the I have the hypotenuse, right? So I'm going to use cosine. Cosine of 60 degrees equals adjacent over hypotenuse, right? X over 36.
So 36 cosine 60.
Yeah, so if I times both sides of this equation by 36, we get 36 times the cosine of 60. So make sure your calculator's in degree mode and go 36 times the cosine of 60. Tell me what you get. 18. Okay, now, we know, so this is 18, did you say?
Wait, you got 18. No, the distance.
Well, he's right. The answer is 22 feet. But the reason he's saying that is because this is, so the distance from, this distance here is 18. We know it's 36 from here to here. So 18 plus 18 makes 36, right? So the distance from here to here is 18 plus 4, which is 22 feet. So this distance right here, we found this. That was x. That distance right there. It was 18. And we know, remember this to here is 36, because that's the radius distance, right? So this distance right here, this radius, is the same as this distance from here to here. It's 36. Well, we just figured out that this is 18, and so that's 18, which makes this 18.
But shouldn't we know that before? Because 30 is half of 60. So
You are right. That's the way we should have gotten it right there. Good job, Trevor. Because this, on the unit circle, we know the cosine of that 60-degree angle, the cosine of 60-degree angle is 1/2, right? That's what we should have done. I knew there was a way to use it using the unit circle. I wasn't thinking about that. Okay. It's recording. What? Is that what you're asking? Okay. So, yes, Haley. Okay. Well, when we got this, see this circle, I mean this triangle right here? We just figured out x. We got 18. Do you understand how we got that? Well, that's this same triangle right here. See that? So, and this distance right here is the 18. Okay? So, if you notice, from here to here is a radius. That distance right there is 36. So that means that 18 plus 18 is 36. So if we cut it in half right here, that 18 plus that 18 makes 36, right? So, and if we just go straight across to right there where this guy was sitting in his seat, okay, he was 18 feet from the bottom if he was sitting on the bottom of this Ferris wheel, right? So that's 18 feet there plus the 4 feet to the ground makes 22. Okay? All right, now part C. Suppose the radius of the Ferris wheel is only 30 feet. How far above the ground is Domingo after the Ferris wheel rotates 300 degrees? Okay, so instead of 36 feet, he's 30 feet. So it's 15 plus 4, which is 19, because it's half, right? Because the 60-degree angle, the cosine is 1/2. Well, they're saying, what if instead of the Ferris wheel being a radius of 36, it's 30? So we just take half of 30 is 15. It's going to be 15 plus the 9. Okay, and then part D, suppose the radius of the Ferris wheel is r. Write an expression for the distance from the ground to Domingo after the Ferris wheel rotates 300 degrees. So what's the expression we're going to write?
300 something. That's
Half the radius. And then what? And then adding 4. That's it right there. Whatever the radius is, you take half of it, and you add 4. That's because on the unit circle, we didn't really need right triangle trigonometry to do this. We could have used the unit circle. Big circle.
wow, that was a really good circle.
Okay? 4 feet right here, right? Okay. This guy rotated 300 degrees from right here. He rotated around 300 degrees to right there. Got it? Okay. That's a 60-degree angle because it was 300 plus 60 makes 360, right? Well, we learned if we draw this line straight across here and make a right triangle, we learned that in a 60-degree triangle, okay, whatever the radius is, if this was 36, then this is half of that. It's 18, right? Okay? So right here, where he's at, so that makes this 18. From here to there is 18 as well, right? Because 18 plus 18 makes 36. This is a radius from here to here, isn't it? Okay? So this distance from here, even with that, is 18. To the ground is 4. 18 plus 4 makes 22. I went over it, after I figured it out, I went over it twice. Were you guys talking back there? Okay, we got it? Okay, is that it for that assignment? Okay, we're moving on. So the objective for today is to use trig to find the lengths of the sides of right triangles. I'm giving you that the length of this hypotenuse is 14. We have a 35-degree angle right here. One of the acute angles is 35 degrees. It is a right triangle, so we can use right triangle trigonometry on here. I want you guys to find Q and P. Use right triangle trigonometry, SOHCAHTOA, okay? In your groups, I'm going to give you a couple minutes to find Q and P. Now, you guys, last time I did this, all of you seem to know, all the tables knew it, but if you're just copying off of someone else, ask them to teach you. Don't just copy down the answer and say, I've got the answer. Copy down. Okay, JD. This is Q. That's length Q. Yeah, you guys, angles are named with big letters. So big P, big R, big Q. Sides are named with little letters that are opposite. So here's big Q, opposite of that is little q. Here's big P, opposite of that is little p. Here's big R, opposite of that is little r. Is that what you're asking? JD? Yeah, you can have little q and big Q. Little q is a side, big Q is a point, or a vertex. Okay, I'm going to give you a minute. Go. Okay, listen. I just want to do one of them with you. I want you to do the other one. Let's say I wanted to find P. Okay? I need to set up an equation where I have only one unknown. Okay? In this case, my unknown is going to be P. That's side P. Okay? Now, I have three different choices to use. I have sine of P, big P equals opposite over hypotenuse, or I can use cosine of P equals adjacent over hypotenuse, or I can use tangent of P equals opposite over adjacent. Now, if I use tangent, I'm going to have two unknowns, am I not? I do know angle P, so on all three of these, angle P is 35 degrees. I can plug 35 degrees in there, right? But on this one up here, I don't know either P or Q, so I'll have two unknowns. Can we solve an equation? If we have one equation, can we solve it with two unknowns? No. We can't. So you want to set up your equation so you only have one unknown. Well, so I'm going to use one of the ones that has a radius. So if I use sine, my angle P is 35 degrees, is equal to P, that's the side opposite, over side R, which is hypotenuse. I know hypotenuse. Now I only have one unknown, and I can solve my equation. So I can get P by itself by timesing both sides by 14. These cancel out, and so P is equal to 14 times the sine of 35. I plug that into my calculator. I've got my answer. What is it? It's P. Which one's? 8.03 is P, right? Okay? Now, Q, if I want to know Q, I'm going to use the cosine one because I have R and I have angle P. So I'm going to go cosine of 35 degrees equals Q over R, which is 14. Now, once again, I do the same thing. I times both sides by 14. They cancel out, and so 14 times the cosine of 35 is equal to Q, which is 11.47. Any questions? Okay, that's how you do right triangle trigonometry. You find the equation that you're going to only have one unknown in. Okay, here we go. How many of you had that, by the way, already? Okay, excellent. I think most of you did. Some of you guys are struggling. Okay, here's a go. Next problem. How long is R and how long is D? So, let me erase this. So, you guys, this time, these equations set up a little bit different. This time, I don't have a hypotenuse like I did last time. I have, from the 52 degrees, 15-minute angle, I have the opposite side. I want to know adjacent. I want to know hypotenuse. Okay? So, first of all, we change 52 degrees and 15 minutes into decimal degrees, which is going to end up being 52.25, right? So my angle is 52.25 degrees. Now, I have opposite. I want to know adjacent. Opposite and adjacent. Opposite and adjacent. Which one is that? Tangent. Okay, so I go tangent of 52.25 degrees equals opposite over adjacent, right? Now, a lot of you guys, this is where you guys got stuck. You didn't know how to solve an equation like that. You guys, this is simple algebra. This is stuff you learned in 7th grade, how to solve an equation like this.
Can I do it?
Okay, just tell me what to do. What would you do?
You would times the other side by D and then divide by 52.2, and so you get 40 over 2.
That's exactly right. I'm going to write each step out, though, for these guys to see. You times both sides by D. The D's cancel out on the right side. Now you have the D out of the denominator. You have to get the D out of the denominator first, right? So we did that. And now D is being tangent times by tangent of 52.25. So to get D by itself, I divide, like Kayla was saying. These cancel out, and so your answer is 40 divided by the tangent of 52.25. What did you guys get? You go 40 divided by the tangent of 52.25. Okay? Well, yeah, you can, now that you have D, you can do that. But the problem with D, hey, you guys, let me tell you what the problem with D is. The problem with D is that it's an approximate answer, 30.97. So if you use D to find R, you're going to get a little bit further off. You'll be pretty close, but you'll be a little bit off.
No, find the top. Like
Oh yeah, you can find the top angle. What's this angle right here? It's 37.75 degrees, right? That's not going to change anything. D is still going to be on the bottom. Opposite. D over 40. Oh yeah, you could do that one. You could use tangent. Yeah, you could do that. Yeah. Yeah, you could do it that way. Hey, by the way, you could have also, from here, you could have used the cotangent. Cotangent of 52.25 equals adjacent over 40. So you would have 40 times the cotangent, but of that equals D. But you got to remember, cotangent's not on your calculator, so you'd have to put it 1 over it anyway. So you'd end up putting the same thing in the calculator. Okay, next, right here. I need you to understand angle of elevation. The angle between horizontal and the line of and line of sight looking up.
Wait, how are we supposed to find R?
Oh, we didn't find R. But you should be able to find R. You have both of these, right?
They do algorithmic.
Well, I need R. And so I need hypotenuse. I have side opposite, right? So which one's that? I could use the sine 52.25 equals opposite over R. Or I can use the cosecant of 52.25 equals R over 40. Or you can use the Pythagorean theorem. The problem is this is an approximation. Yeah, well, our answer, but if we're using, the first time we're approximating an exact answer. The second time we're approximating an approximate answer. And you're going to get further and further off every time you do that. That's the problem with it.
Oh, I hate this.
Okay? So cosecant of 52.25 equals R over 40. You can use either one of these. The only problem with this one, yeah, you're going to get the same thing. When you put 40 times the cosecant of 52.25 in your calculator, you have to put 40 times 1 over the sine of 52.25. Yeah.
Last time you used like the opposite angle of that.
Guys, the question is, how do you know which angle to use? You use the angle you have. Since I have this angle, well, I really have all the angles, so it doesn't matter which one I use, unless, like you guys used a good strategy. You can't use 90. Guys, 90 is the right angle. You got to use one of the two acute angles. With SOHCAHTOA, you have to use one of the two acute angles. Okay, angle of elevation. Guys, look, right here, all eyes. Angle of elevation is the angle between horizontal and looking up at something. So, right here, if I want to look up at the corner of where my ceiling and my wall come together, my angle of elevation is between horizontal and looking up. So it's this angle formed right here. Okay? I'm doing too steep. Right there. Horizontal and looking up. So it's this angle. So you can see a picture of this guy. Here's horizontal. Here he's looking up. That's called the angle of elevation. So if you're looking up something. Angle of depression is looking down. It's between horizontal and looking down at something. You can see the picture right down here. Okay? Looking down at something. Look. These are just definitions of words. It's not hard. Okay. Yes. Okay, right here, you guys.
Wait, can you go back to that? I want to write that down.
Okay, write it down quickly. 7 problems. Oh man, I'm being too easy on you guys.
No, you're not.
Oh yeah, that's your Christmas present. I forgot. Okay, Merry Christmas to all of you.
And ours was everyone coming.
And yours was everybody coming today. Except for McKinley. She was AWOL.
You said that everybody.
Huh? Did your brother leave this morning on his mission? Yesterday? Where did he go? So you went to MTC in Mexico? Went straight to Guatemala? Which MTC is he going to? Is there an MTC in Guatemala? I bet you went to Mexico. Okay, this is how you're going to memorize the unit circle. Really, there's patterns to this. Okay, there's very good patterns to this. So I've given you all a blank unit circle chart, and you guys are going to fill this in. I'm going to get you on going on each pattern, and then you're going to finish filling them in. Does everybody see the line that has the degree mark by it? We're going to start with degrees. Okay, now obviously this first one down here is 0 degrees, right?
0.
Now we have 30-degree angles. Some of these go around in 30, some of them go around in 45. So without looking at the unit circle up here, don't just fill it in. You've got to understand how to memorize it because you're going to be having a quiz on it on Friday. Okay, so I know the next line is 30 degrees. And then don't worry about the 45 one right now. You guys, I got to teach you the pattern. Okay? we're going to go every 30-degree angle. The middle one is 45 degrees, so we're going to skip that one. We're going to go to this one and say 60 degrees. So we have 0, 30, 60. What's 30 more is 90. So this one right here is 90 degrees.
Then 120.
Then you add 30 to 90, and you get 120. Skip the 45-degree line in the quadrant 2. And you add 30 to 120, and you get 150. I want you guys in your groups to finish filling that out in degrees all the way around, except for the 45-degree angles. I'm going to give you 30 seconds. Now, let me teach you this part. Okay? Now we're going to do the 45 degrees. 0 plus 45 is 45. 45 plus 45 is 90, which we already got that one filled in when we did the 30-60, right? 90. Okay? 90 plus 45 is 135. You can use your calculator, add if you need to. 135 plus 45 is 180. Okay, I'm going to let you finish filling that in. Just add 45 each time around. Yeah, that's what it's going to be. Yeah. Up in the upper right corner somewhere, I would write, do all the 30-degree angles. That's step 1. Step 2 is do all the 45-degree angles. Okay? All right, so then you're going to have all the degree measures in. Now, I'm going to erase this so mine doesn't get all cluttered so that you guys can follow along. Now, radians follow the same pattern, except for all the 30-degree angles are equal to pi over 6, right? If you look up here, 30 degrees pi over 6. Now, we're going to add pi 6 every time instead of 30 degrees, right? So my first angle is 0 radians. Remember, if we don't put a degree mark by it, it means radians. My first 30-degree angle is pi over 6. Now, what happens when you add 1/6 plus 1/6, you guys? You get 2/6, which reduces to 1/3. So this one right here is pi thirds, but it's really 2/6. Okay, 1/6, 2/6. What comes after 2/6? 3/6. But what does 3/6 reduce to? 1/2. So this is pi halves. Okay, so we got 1/6, 2/6, 3/6, 4/6. What does 4/6 reduce to? 2/3, right? So it's 2 pi over 3. So you add 6 every time. So 1/6, 2/6, 3/6, 4/6, 5/6. And that one doesn't. So 5 pi over 6. So this one doesn't simplify. 5/6. What comes after 5/6? 6/6. But 6/6 is equal to 1. So 1 pi.
And then you do the negatives, which is...
No. Keep going this way. Okay, what? 7/6 comes after 6/6, right? So 7 pi over 6. So now we have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6. What comes after 7/6? 8/6. What does 8/6 reduce to? 4/3. So 4 pi over 3. And then after 8/6, you get 9/6. 3 will go into 9 3 times and the 6 twice, so 3 halves. 3 pi halves. So that's 9/6. What comes after 9/6? 10/6. What does 10/6 reduce to? 5 over 3. After 10/6 comes 11/6. And after 11/6 comes 12/6. 12 divided by 6 is 2. So 2 pi. All right. Now, do you think you can do that?
Oh, we're so good.
So what are you adding each time?
1.
Okay, so your third step, step 3, is to add pi 6. all the way around. Pi 6 on your 30-degree angles. What about our 45-degree angles? What are we going to add each time? Pi fourths. Now, that's what I said. You're going to have to memorize the first quadrant. Really, you got to memorize 30 and 45-degree angles in radians are pi 6 and pi fourths. So the next step is to do pi fourths. Now, that's 1/4. What comes after 1/4? We add 1/4 to 1/4, we get 2/4, which is 1/2. We've already got that one written in here. 3/4. So 3/4 is 3 pi over 4. 4/4 is 1. So 4/4 pi is 1 pi. After 4/4 comes 5/4. Then 6/4 is 3 pi over 2. And then 7/4. And then 8/4, which is 2. 8 divided by 4 is 2. Yeah, I told you there's a pattern to it, right? There is a pattern to it. There's even a pattern to the other numbers. Okay, we got that down. Okay, so step 4 is to add pi fourths around. Step 4, write that one down. Step 4 is to add pi fourths around. Step 1 was to add 30 degrees around. Step 4, 45 degrees around. Step 3, pi 6 around. Step 4 was pi fourths around. Okay, now, the next thing we have to do is put in our points. Now, I always like to start with the quadrantal angles, right here, 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 and here. We know in a unit circle that this is a radius right here going out, right? So the x number is 1, and the y number, we didn't go up or down, so it is 0. So the x number is 1. The y number is 0. See if you guys can fill in the others using that. You guys.
What'd you say?
This is 1, 0 because the distance from here to here, this is a unit circle. That's a radius. On a unit circle, the radius is 1. So you went to the right 1, and you didn't go up or down. So 1, 0 is your coordinate. 1, 0. What's this one? 0, 1. You didn't go left or right, but you went up 1. What's this one? And what's this one? Okay? That's pretty easy, isn't it? So far, you guys got like 2/3 of the points on your quiz. You got already 70%, right? Like I told you, I expect you to get 100% on this. Over half of you will get 100%. Some of you guys will miss a couple here and there because you just make a minor mistake. Some of you will, there might be 1 or 2 of you bomb it. I hope none of you do. Carissa. 66 points.
Holy, do you want to kill us?
Actually, you guys, yeah, these are test points. The only thing is, hey, the only thing is, I only make it worth 1/4. So 66 divided by 4, what is that? 17. It's worth 17 points. It's a quiz. It's a 17-point quiz. But, hey, this can do a lot to help your grade out. 17 points. If you get all 17 points, okay, if you get all 17 points, 17 out of 17, that will boost your grade. Okay, now, next. The pattern goes like this, okay? You just kind of, you guys remember that this triangle right here is this is half of a equilateral triangle. Okay, so we know that this is the 30-degree angle, which means that has to be a 60-degree angle. A 30, 60, 90-degree triangle, remember, is half of an equilateral triangle. See that? It's half of it. Okay? So when you cut this side right here in half by going right down the middle right here, okay, see, right now this is 1, and this is 1, right?
Yeah.
When I cut it in half by drawing this line through it right here, this equilateral triangle, it instead of it's 1 to here from here to here, so how far is it from here to here? It's half. So your y value right there is going to be 1/2, right?
That's weird.
So I'm just teaching you which one's 1/2. Now you're going to I showed you why the other side's square root of 3/2 because on a 30, 60, 90 degree triangle, the long leg is the short leg times the square root of 3. So if you times square root of 3 times 1/2, you get square root of 3/2, right? On a 30, 60, 90 degree triangle, the long leg is the square root of 3 times whatever the short leg is. Since the short leg's 1/2, square root of 3 times 1/2 is square root of 3/2. Now, you probably should memorize this one. I also showed you how that this one right here is square root of 2/2, square root of 2/2, right? Now, if you just know those two right there, the rest of them are all the same except for the signs. And you got to know when to flip them. Instead of this one being a 30, 60, 90 degree triangle, it's still a 30, 60, 90 degree triangle, but it's been turned right there. So how far is the x distance? It's 1/2. And how far is the y distance?
1.
Square root of 3/2. In other words, you just switch these two right here. Okay? So 30 degree and 60 degree angles, those things are just switched around. Okay, now I'm going to erase this part right here. Okay, so now everything is a reflection. Okay? So I'm gonna draw this in right here. This one reflects over to this one.
What?
This one reflects to this one, and this one reflects to this one. The only difference is my x numbers going which way? Negative. So it's the exact same numbers except for the x numbers are all negative. So negative root 3/2, comma 1/2. Y's not negative, is it? Negative root 2/2, comma root 2/2. And 1/2, comma negative 1/2, comma root 3/2. So you see how those were reflections?
Yeah.
Okay, going down this way. This one is a reflection of that one. This one, a reflection of that one. And this one is a reflection of that one. Okay? The only difference is x and y. You go left, so x is negative. Y is down, so it's negative as well, right? So this one's negative root 3/2, comma negative 1/2. Negative root 2/2, comma negative root 2/2. This one right here is negative 1/2, comma negative root 3/2. It's just that same thing. And guess what? This one's a reflection of that one. This one's a reflection of that one. This one's a reflection of that one. And so you get, the only difference is which one's negative here? Y. So root 3/2, comma negative 1/2. Root 2/2, comma negative root 2/2. And 1/2, comma negative root 3/2. Any questions there?
No.
66 blanks you got to fill in. Now, I put a blank one on the back as well so you could practice. I would try and do it all by memorization. If you need a hint, go look at what you did on the other one to try and help you. Next time you come to class, we're going to have a quiz on this. You're going to have to fill it all in. Do you guys think you can memorize it now?
No.
Honestly, you guys, I'm going to put some pressure on you. I expect you to get 100%.
I don't.